So welcome, good morning, everyone. We're already at lecture number 9 out of 13 in total. So we're nearing the end of the lecture session. I have heard nothing about the exam and exam dates. It's probably somewhere in the week of 14 December, but let me know if you know. Also, we're also kind of heading towards the deadline for the business plan. As you know, this week on Wednesday, Thursday, and Friday, we have the second work group sessions in which you present the second part of your business plan. So for this work group session, you present the organization in which your innovation is situated. It can be your own organization. If you build an organization around the innovation, like a small startup, but it can also be situated in a larger organization. So what you need to do is explain the organization, explain the structure, culture, strategy of the organization, and explain the information systems, the main information systems in your organization. And those should be the systems that that are most important for your organization to function, based on the information flows in the main information flows in your organization. So, for example, if you have an innovation that sells some certain product to a customer, there's an information flow going from the customer to your organization, so specifically to the order department, and then information flows to the production department, etc. And those are information flows you need to describe, and probably you need to have systems to make sure that will happen. So probably maybe a website for a customer or an app where a customer can order stuff. An order system in your organization, so things like that. So you don't have to explain in technical detail how the information systems work, but you do have to explain, okay, what would be the most important systems in our organization. So please take that into account when preparing the presentation for this week, and also for your business plan, of course. I hope that answers your questions, Margot. Let me know if you have any additional questions. So this for this week, it will be the similar setup as last time, and you can find all the information and the schedule on Canvas. Today we'll be talking about databases and database design. So database is a very extensive topic, and you're gonna have, if you do computer science, you can have multiple courses on databases and database design. We're not diving into that much detail into databases, but I think, and that's why it's included in the course, it's good to know a bit about how databases work. And the reason is, this is a lecture needed for a database assignment. And the reason is that databases are everywhere. So every technology, so every information technology you use, probably every app you use, is basically structured around a database. If you use Google, you query, as it's called, so you tap into the database of Google. So they're far more complex than what we'll be seeing today. But the whole, how Google works, how the Google search engine works, is based around a huge database which contains information about all the websites that Google Google spiders, as it's called. That's in basically the entirety of the web. So that's the database. If you use Facebook or Instagram, if you post something on Instagram, if you like something on Instagram, if you post a comment on Instagram, it's all stored in the database. And if you go to Instagram and watch your timeline, it's also, the web page is also built up from a database. So databases are like really central, really the core of many different applications. Even the phone is also, the contacts in your phone are also a database. The way your phone stores certain other information is also based on the database. And that not only goes for the tools we use in our daily lives, but also for how organizations work. So last week we talked about enterprise resource planning systems. So they have a database at their core. Customer relationship management systems, also a database with information about customers. So you will use databases and database interfaces when you start working, if you are doing it already. And I think it's good to know something of how databases work. And I also think it's a good way of thinking. So thinking about, okay, how is data exactly ordered? How is data related to other data? And I think it's a good way of thinking logically about the structure of something, which also helps you in, well, I think it helps you think. So let's get started. So first of all, explain a bit about what a database is. Yeah, if you now have specific questions about the business plan, maybe it's better to ask them by email. So I think I need a lecture. I need a lecture to cover databases. So I'll answer your question by mail. So if you can mail it to me, because it's not so relevant for the other students, I think. So databases. Well, I think I already explained this slide. So databases help you think. Databases are the base of all information systems, and it's also one way of modeling information. So in lecture 5, we discussed information flows, which is a very broad way of thinking about, okay, what information do we need where in an organization? And database design is very narrow. It's really thinking about, okay, what exactly do I need? What data do I need in my spreadsheet? So this is a spreadsheet. And if you, a database is not really an information system on its own. You know, a database is just a spreadsheet. So this, what you see on screen now, is part of a database. And if you have multiple tables connected to each other, it's a database. But it's not an information system yet, because what we discussed last week, it only becomes an information system if you combine it with how people use it, if you combine it with processes and with how humans use the database, the system, and then it becomes an information system. A database is nothing more than a hard disk containing lots of data in a structured way. And for example, if you see the spreadsheet on screen here, it's a single spreadsheet can be seen as a database already, but this is not an information system yet. Only when you know what it's about. So when you know, okay, this is probably customer information about how many. So maybe this is from Albert Heijn. You know, maybe this is how many products a certain customer bought. Then it becomes an information system. So a database on its own, no, it's just a technology. A database that is used by people for a certain purpose, yes, that's an information system. So at its core, a database is just a bunch of spreadsheets, just a bunch of tables in a certain system, and they are connected to each other. And also a single spreadsheet can be seen as a database. It can be used as a database. So for example, your agenda is basically a kind of a spreadsheet, and it can be seen as a simple database. But if you think about spreadsheets only, if you think about the table in the spreadsheet, so specifically if you think about this table, there is a lot wrong with this. It has so you can improve spreadsheets a lot and turn it into a database. So if you look at this spreadsheet, what would you say is wrong? So what would the disadvantages be of storing data like this? Say this is the way that Albert Heijn stores who bought which data. The date. Why? Yeah, so it's not yet. Well, regarding dates, there are several ways you can store a date in a database, and you have to say to a database which is the date. If someone moves, you have to update all the records in the database, which will probably never happen, so you get a lot of errors. You cannot get a good overview, indeed, of the products that the company sells. Yeah, and each product bought by a single person gets a separate place in the database. So I don't think there are doubles here, but if Mr. or Mrs. Willems would also buy, oh, here's stroopwafels. So Willems bought stroopwafels and Janssen bought stroopwafels. So it's very difficult to get an overview of how many people actually bought stroopwafels for the organization. Furthermore, what would happen if suddenly prices go up? Because Janssen bought one stroopwafel for one pack of stroopwafel for €2.65. Then what would happen if stroopwafels suddenly become €3? So you would have no idea of knowing for how much Janssen actually bought the stroopwafels in the first place. So actually storing data like this, especially if you get more, so if your organization grows bigger and you need to store more data, it is not handy to store data in a single spreadsheet. So if you look at this, you can immediately think, maybe we need some kind of separate tables. So maybe we need one table which stores product information. So stroopwafels, how many stroopwafels do we have in store? How much do they cost? And maybe we need a separate table with customer information. So with customer address, customer number, and then maybe we can connect those two to each other. So maybe there's a way to connect the customer information with the product information. And then we have one table with product information, and we can know how much is bought from a certain product and how much it costs. And we have information about customers for a customer relationship management system. So you can immediately see that it's probably handy to do this to split this into separate tables and then try to connect them to each other. And that's what a database does. So what's wrong with spreadsheets? Well, for technical thing, this becomes huge quite quickly, because every time Mr. or Mrs. Janssen buys something, you have to store all the information about Mr. or Mrs. Janssen in the database again, instead of only one time the address. Oh, Mariana, I got to your question in a moment. So it becomes very slow, especially if you have to search through a database. So it contains redundant data. So what if Janssen moves? What if you make a typo in a product name? We call this stroopwafels or stropwafels. And how do you reason using spreadsheet data? So what would happen if you want to combine data about families, about neighborhoods, etc.? So it has a lot of disadvantages. But then you only know the total number of sold products instead of linked to each customer for getting to know your customer. Yeah, we're getting there. Yeah, Marijn, that's actually a good question. So because in what I just said, you have two separate tables, but you need to connect them. And there is a way to connect them into a database system, and that's really the core and the power of databases. The way to connect those tables to each other so you know who has bought what at what time. But we're getting there with a simpler example. So what should a database do? So you should have fast access, so it should not have redundant data. So, for example, it should simply be possible if Mr. or Mrs. Janssen moves to simply edit one row in the database and be absolutely certain that the address has changed instead of updating it into multiple tables and multiple rows in the table. So you want to represent relationships between data, which I'll get to in a moment, and you want it to be fast. And that's why we need a database. More interesting, what is a database? Well, the grayed out part is a self-describing collection of records, but that's really a technical definition, which is pretty useless, I think. Actually, what a database is a collection of data which is organized in a certain way that can be accessed by other applications. And with other applications, I basically mean other people who all can use part of the data in the database. So that's a database. Concretely, if you think about what does a database look like, well, a database consists of tables. So simply an Excel table like you've all used, or an SPSS table if you now take statistics, that's basically the core of a database. So a database consists of tables. It consists of relationships among those tables, and it consists of metadata about tables and relationships. Well, what is metadata? Metadata is a definition of the type of data. And I'm not sure, I think you've all had something to do with SPSS by now. And if you've ever opened an SPSS file, there are two ways of viewing the SPSS file. So one of them is just simply data, like the Excel sheet. And the other one is the definition of all the variables. So the other view of the data in SPSS is, okay, variable number 1 is a text file, this is the label, this is the description, etc. That's metadata. That's data about data. So for example, I forgot who, but someone said the date here. Well, when you create a table, you can tell the table or tell the software, okay, this is a date. And Excel does this automatically, but you can also do it manually. You can specifically say, okay, if I type in 14/09/01, it's a date. And specifically, it's day, month, year. And that's metadata. So basically, a database is nothing more than that. A database is just a collection of tables, basically your average Excel table, with information about the table, which is the metadata, and the relationship among those tables. That's a database. Well, how is this organized? This is kind of the hierarchy of a database. The data view in SPSS, raw data, I forgot what the data view in SPSS is. It's the data view where all the data is, because that would then be raw data, or just be the data. So you have the data and the metadata. And basically, everything in a database is raw data. And if you then convert data into something else, then it becomes other data, or it becomes specifically information. But in a database, there's not real difference between raw data and data. It's just data in a database. So yeah, the data view in SPSS provides the data, and the other view, I don't know how it's called, but that provides the metadata. So this is on screen now is the organization of a database. So of course it starts with bits and bytes. So a bit is a 0 and 1. A byte is a simple character which you can store in a database, like a letter or a number or whatever. And what we call a field is a group of characters. It's a bit complicated because we also call a field a variable. We'll get to that later. But a field is just what you call in SPSS or in Excel a cell. So a record is the row. That's a group of related fields. So the row is basically all information about a specific customer, about Mr. Jansen. A file in a database is a table, and a database is a group of related files. And yes, every data table in a database always has a metadata table that describes the data. So even if you just type stuff into Excel, in the background, Excel will create a meta table with Excel's guess about what kind of data it is. So if you enter a number, Excel stores somewhere, okay, so this field is a number. If you type text, then Excel knows, okay, this is a text. So every data table in a database always has a metadata table. And in Excel, you usually don't have to worry about it unless you enter something and Excel suddenly thinks it's a date and messes up your whole complete data. And that's because Excel doesn't know correct metadata. So a bit more, so the previous slide, but then a bit more clear. So this is a basic table. So the whole thing is called a table. The table is called supplier. The table has certain columns, which basically are the variable names in SPSS, but in Excel we call them, it's the columns, and we call those in a database attributes or fields. We usually call them fields. So the rows in a database are called the records or the tuples. Tuples is really a technical term, but so we usually call them records. And a cell in a database is simply called a cell, and confusingly sometimes also called a field. In general, we call them cells in a database. So the row gives information about a certain thing. So, for example, the row gives information about supplier number 8259. We know the supplier is called CBM. We know the street, the city, the state, and the zip code. The attribute supplier street contains all the street names and numbers of the different suppliers. And in total, it becomes a table. Now, you can distinguish. So some people call a field, so an attribute, also call it a field as a collection of fields in a column. Other people only call cells field, but in general, it's so, especially here in this course, but also in general, when we talk about fields, we mean the columns, and when we talk about cells, it's just the cells. Yeah, and then we have the key field, and the primary key is, that's really the subject. So a primary key uniquely identifies a row in a table. So for example, you are students. What is your primary key as students? You have two. So student number. Yeah, so a student number is your primary key because there is no one in the university who has the same student number as you. And you have both an ANR and an SNR, and that's because we as a university are stupid and we still use two different systems. But you can be absolutely certain that your student number is unique. Your name, your birth date, doesn't have to be unique. So that's why we give you a student number when you enter the university, because we are definitely sure that that's unique. And when we submit grades, we always submit grades with your student number and not with your name. So we are certain we give the grades to the correct students. So that's a primary key. So a primary key uniquely identifies a row in a database. And sometimes you have a primary key which is kind of logical. So for example, for a bank, your bank number is very well be the primary key. But sometimes you just have to give rows in a database a primary key. So you just number them from 1 to infinity. Yeah, so the student number. So that's the primary key. And that's actually pretty important because so even with combinations of student names and birth dates, you can never be sure that you have that it's unique. So that's why we have primary keys and student numbers. And that's why you have social security numbers. That's why you have a bank account number. That's why you have a phone number. You all have those numbers, and you all have to remember those numbers because those are primary keys in databases in a system somewhere. That's the only reason why you have a bank account, to uniquely identify you. That's why you have a bank account number. So this is a table. The second thing that a database has is relationships among those tables. So we're going to dive a bit more in detail about that in the second part of the lecture. But using those primary keys, so using those unique identifiers, you can create relationships among those among the tables. So let's say this is a fairly basic example, also not a very good example, but just to make it a bit simpler. So this is an example. So basically say we have one table with student information, the student table with name, and I have no clue what HW1 and 2 means, but because I nicked it from from a book chapter. But we have one table with student number and all information about students. Oh, homework. Ah, yes, great. And we give Andrea Baker student number 1325. Say we have another table in which you want to keep track of the email messages that students sent. But we want to keep track of that in a separate table because we don't want to have lots of columns attached to the student table. So we want to keep it in a separate table called email. But of course, we do want to know who exactly sent that email. So we have an email number, a date, we have the message here, and we add the student number. So we don't add the student name, we don't have to add HW1 midterm and all the other information that would be in the table. But the only thing we have to do is simply add student number, and then the database can automatically figure that out and can say, okay, student 1325 is Andrea Baker. So simply by adding the student number to the email table, you immediately connect. You can immediately connect a specific email to all the student information. For your business plan, you don't need to do anything with the databases because that would dive into too much detail. So unless you really enjoy this and would really and it would really make an addition to your business plan, that's okay. But for your business plan, just a general overview of what type of information is needed in your organization is enough. You do have to do this, exactly this, what's on screen now, for the database assignment. So for the database assignments, you do have to visualize the tables and the relationship between tables. So this is the relationship between tables. I have a couple of more examples later on. Finally, this is in a previous version of Access. Access is Microsoft's a simple database program by Microsoft. And this is how the metadata is explained in Microsoft Access. So for example, the email is an auto number and we describe it as a primary key. The date, we call it, that's a date time type of data. And our description is date and time the message is recorded. So that's metadata about email number, date, message, and student number. So student number is a number and our description is foreign key to row in the students table. So this is metadata. This is also metadata, only a bit complicated. Yeah, oh, exactly. Absolutely. Yeah, metadata is exactly like a code book. Yeah, absolutely. Yeah, yeah. It's just a description of the fields. Yeah. So basically, tables, the relationships among the tables, and specifically among rows in the tables, and the metadata together what makes up a database. Now, you don't need to make a metadata table for a database assignment. What you need to do for the database assignment is simply provide the relationship between tables. But I'll get to that later. So, okay, I have just 2 slides about a database management system. So, because a database, it's really what happens technically at the core of in the database, what happens in the computer program itself. But when you use a database as a person, you use a database management system. And probably other applications like your customer relationship management software, or for example, when you open up Instagram. So let's take that as an example. So when you open Instagram, the app Instagram connects to the database management system of Facebook, and that kind of gets all the different data from the different tables and that displays it to you on screen. And in order to make that work, you would need a database management system. And a database management system is a way for us and a way for other applications to access the data in a database system. So a database management system is the software that you use to create a database, that you use to edit the database. So it's like the interface between the data which is actually stored in the computer and us. So it's the interface between applications and the physical data files that contain the tables. And the database management system, so you don't have to remember everything that's on the slide, but the database management system basically takes care of all the data handling. But of course, we have to tell the database management system what the tables are. We have to tell the database system what kind of data it is. So we have to give the metadata to the database management system. And we have to tell the database management system what the relationships are between tables. Because a computer cannot do that. A computer doesn't know that 88 and 100, that 88 and 100 is homework. As I didn't know that. So for a computer, this could just as well be the primary key, or this could be someone's name. A computer doesn't know anything. So you have to tell a computer 88 is homework assignment, is the score for homework assignment 1 probably. Student name is student name. Student number, that's the primary key. So you have to tell a computer everything. The computer doesn't know anything. And that's what you have to tell the computer in the metadata. And that's what you use the database management system for. Do we also need to name everything for the database assignment? I'll get to that in a moment. So so you have to indicate primary keys and you have to indicate tables, but I'll get to that in a moment. So a database management system basically is a system that does three things. So a database management system has all the physical stuff in place to make sure that you can actually enter data into the database, which is the data definition capability, so the structure of the database that you use to create tables. It has a data dictionary, which you use to store the metadata, and it has a data manipulation language. And that's the way that you can access the data. If you looked at the slides for this lecture, there are actually a bunch of hidden slides in this PowerPoint presentation. Those are slides for people who find this topic really interesting and who maybe want to do something with it further. And those slides explain how you can actually tap into a database. Because there is a language to do that. There is a program, well, not really a programming language, but a kind of programming language that you can use to access data in a database. So, for example, can I just write something on my just a moment. So if I want to select all information about all students in a database, I can just type in select everything from, and let's say the table is called students from students. So if I type in this into the database system, is there a buzzing sound again? Again, Jesus. Okay, is it gone? Worse. Okay. Maybe this one. And now? Better? Okay. It's because the fan of my computer is spinning a lot. I think it's messing with the microphone. So I now just turned on the microphone of my webcam, which is far away from my computer. So I think that's why it's gone now. So this table is called student. So if I type in, select everything from students, I will get the table. So if I want to have, for example, only students who scored higher than a 90 for their midterms, I can just type in something like maybe higher or equal to, I could just type in something like that. And that's the way you can access information in a database. You can forget this immediately, but this is a way that that you can access information from a database. And basically, when you let's again use Instagram, when you go to Instagram and you get your feed actually behind the screens, your request, so basically getting access to your Instagram feed, is translated into a language like this. And this makes sure that the database can access and gets the right information, which is then in turn displayed to your screen. So this is what happens behind your Instagram page and behind every other database. Okay. So that's what the basic database system does. So it provides the interface between the database and you. Okay. So now we're getting to the database assignment. And like I said, it's a good way of thinking about data. So actually, basically, think about, okay, what would happen if I want to store, so for example, you've come up with an innovation right now, say you sell certain products to customers. How do you want to store the data from those customers? Do you create a huge table? Do you create more than one table? How do you make sure that everyone has access to the data? Do you have to separately store first name and last name? Do you do it in one? Well, etc. So so when you would actually build your own business, you would have to think about stuff like that. And those are fairly basic choices you have to make, which are very important for your organization. So, and that's basically thinking about how the database works. So let's think of a very simple example. I'll get back to this slide in a moment. So let's think of a very simple example. So let's say we have so we want to keep track of the students who are enrolled in a certain course at the university. And we want to keep track of the teachers who teach those courses. So again, we have two tables like this. So we have a teacher table with information about teachers. So this is my ANR, my employee number. My name is Schouten. This is my office room, which is quite useful right now. This is my email. And there can be other information in the table as well. But basically, this is a very basic table. Then you have information about the courses that we have at the university. So we have a course BTI, which has 6 ECTS, and a course Social Media at Work. It's also a 6 ECTS. And again, there's probably other information in the table which I don't display here. If it's a bachelor or master course, what are the prerequisites for the course, the description, etc. But I have, for this example, it's just a very simple table. And this is how the data is represented in a table. So the data representation is a two-dimensional table called relations or files, and each table contains data on one entity and its attributes. So this is a table. And a table is always about something that we call an entity. So in this case, the entity is teachers. In this case, the entity is courses. And we call it entity and not persons or whatever, because it can be anything. It can be suppliers, it can be something very technical. So that's why we call it an entity. So this table stores information about the entity teachers. Well, this is basically what we just discussed. So the table is just a grid of rows and columns, and the rows are the records for the different instances of an entity. So basically says something about the teachers for the students. The fields represents the attributes for the entity. The primary key uniquely identifies each record in the table. That's your student number, etc. And a foreign key, that's new information here. A foreign key is a field that is a primary key in another table and then used for looking up records and linking records together. That's confusing, but this makes it obvious. Okay. The bottom table is the entity courses. So the table is about courses. It contains information or data specifically about courses. The rows give information about each entity. Specifically about each instance of an entity. So this row gives information about course number 812233. This row gives information about course number 8421888. A column or field gives information about the attributes of an entity. So it specifically says, okay, we have the entity teacher. So this table is about teachers. And for each teacher, we store ID, name, room, email, and maybe other information as well, birth date, whatever. This is a cell. We already discussed that. This is the primary key. So we know that course ID and also teacher ID is unique. So we are absolutely certain that no teacher has the same ID number. So ID is the primary key. Finally, foreign key is a primary key in another table used to connect two tables to each other. So teacher ID is unique in this table because we defined it that way. So we defined teacher ID, so the ID here, as the primary key in the teacher table. So that is unique. So it cannot be that that's 2 times in the table. Course ID is also a primary key. So every ID number in this table should occur only once. So there can be no courses with which have similar IDs. There can be courses with the same name, of course. You can have a course methodology for one faculty, and you can have a course named methodology for another faculty or study program. That's why we don't take the course name into account, but we take the course ID into account as a primary key. Then, a foreign key is used to link to tables. So here, I enter teacher ID in the course ID table, so I know which teacher teaches a course. So this course, I know it is taught by teacher number 625233. Yeah, no, you're right. That's an error. So you can name them differently because you can just specify. You can just tell the computer teacher ID is linked to this ID here. So you don't have to name them the same, but of course you do need to name them the same because else it becomes confusing for you. So this is actually a one moment. So this is actually a mistake. So it would be way better if this was also called teacher ID. And it would be even better if I would be consistent in the naming and I would also do this with an underscore. So this would be better. So the computer doesn't care as long as you tell the computer that these two are connected. But for you, it's better to name them exactly the same. So the foreign key, so the teacher ID here doesn't have to be unique. So the ID here can repeat itself. So here in the teacher ID, it doesn't have to be unique. It does have to be unique because every teacher is unique in this table. But of course, say that I am going to teach SMW instead of Peter Bruder. I can just type in, I can just do this. And now the database knows, and now we know that I, Schouten, teaches 2 courses, both BTI and SMW. So in this way, we can connect the 2 tables to each other. So simply we can say course ID is taught by this teacher, this course is taught by this teacher. If teachers teach multiple courses, we can just say, okay, this course is taught by teacher 625233. This course is also taught by teacher 625233. And that's the way to connect these to each other. The only thing is, and we'll get to that in a moment, what happens if a course is taught by more than one teacher? And there's no way to store that here. So if our course is taught by me and Peter Bruder, yeah, so you could enter a new column, teacher ID 1. But then what happens if a course is taught by 3 teachers? And what by 4? And how many teacher ID columns should you add? Because you can never be sure. Yeah, so of course, so you're right. So you can do this. So you can simply add there. So I can simply do this. So teacher ID 1, and I can say this course is also taught by this person. So that would be one option. But then I never know upfront how many teachers will be in a course. And so maybe this course is taught by 2, so this is okay, and this course is only taught by 1, and then we have suddenly something that's empty here, and maybe another course is taught by 10 teachers, and then suddenly we have to enter teacher 1 to teacher 10. So we can also solve it this way. So we can repeat it. So we can say VTI 6. Oh. So we can also solve it this way by simply repeating this one with a different teacher ID. So we can now see this course is taught by this teacher, and it repeats here. So it's also taught by this teacher. The drawback here is that now we have redundant data here, because it's not only the name and the ECTS that is duplicated, but it's also the entire course description, the description of the literature. Everything is now duplicated. So if I want to update the course information, so if the course is suddenly called BIT, I have to look through all the records and correct them all, which is difficult to do and leads to mistakes. So there is a way to solve that with an intermediate table. So this is how you connect databases to each other, and this has a lot of advantages if you compare it to simply flat files. So if you compare it to something like this. So here is a list of students, a list of student numbers, a list of courses students take, a list of teachers. So this is a lot of redundant data, because Mrs. Jenner is taking 2 courses. So sorry, there are 2 Jenners. Kylie and Kendall are both taking my course. They're both taking BIT with my, and I teach that. And the only thing that identifies that for me is that they have 2 separate numbers. So this is really, yeah, we have, yeah, model names, absolutely. Oh, yeah, typo. Thanks. So if you store information like this, it's really confusing, because the same error that I just made, I don't know that these are 2 different persons, so I have to rely on the student number. So that's why we have student numbers. So this is just very redundant and very confusing. While if we store it like this, it is way more structured. So this is all kind of redundant data. So what we want to do in order to solve this is we want to introduce more tables. So basically, this is a This is a very simple way of, so this is a very simple system to keep track of students. So we have names of students with student numbers. We have names and information of courses, and we have names and information of teachers. And again, these tables are way more extensive in real life because student information also contains your address, birth date, and other information. Courses contain also other information, etc. So this is a very simplified display of the table. Here you see that we have two k-geners here. So that's why we need the student number in order to make it unique. I just try to come up with something original. But thanks. So we have courses with course ID. So like I said, courses can have the same name if it's courses for different departments, and teachers also have a teacher ID. So how do we connect those to each other? So we can connect those to each other using something which is called an entity relationship diagram. And that is what you have to do for the database assignment. So for the database assignment, you have to create an entity relationship diagram in which you explain how tables are connected. So if you look through the database assignment, you basically see that the case for the database assignments is an organization that now doesn't have a database system. So they basically have two Excel sheets that function independent from each other, and you have to combine them into a database. And the way to represent that is an entity relationship diagram. So what is an entity relationship diagram? An entity relationship diagram is just a description of tables and the relationships between those tables. That's it. And using an entity relationship diagram, you can normalize data. So an entity relationship diagram is basically thinking about the structure of the data in the database. It's quite similar to the information flow modeling we talked about in lecture 5. So it's thinking about the structure of a database. So what data should go where and how is it connected? Yeah, I'll give an example of an entity relationship diagram in 2 slides. And if you do that well, if you design a database well, then your database is normalized, which means it has no redundant data and it works efficiently. So what's an entity relationship diagram? Well, it basically starts out with this. So it basically says, okay, what are the types? So it starts out with what are the types of relationships between entities? So in this example, we presume that students can take multiple courses, but we also presume that each course can also is only taught by one teacher. So a teacher can teach more than one course, but each course is taught by only one teacher. That's not what happens in reality, but that's just to make it easier for this example. So if that is the case, so if you think about, okay, how are students and teachers and courses related? Well, it's as follows. So a student can take many courses at the same time. But a course is also taken by potentially 0 or more students. A teacher can teach more than one course, but each course can only be taught by one teacher. This is called, from lecturer to course, this is called, well, the student and the lecturer have a relationship mediated by the course, which is kind of obvious because I also know you only through the course. So there is a relationship between the student and the teacher, but it goes through course in the database here. I'll get to your questions in a minute. So a relationship between student and course, that is what we call a many-to-many relationship. Basically kind of obvious because a student can take multiple courses and a course can be taken by multiple students. So many-to-many. In this case, we defined that each course can only be taught by one teacher. So of course, in reality, each course can be taught by more than one teacher, but for this example only, we say each course can only be taught by one teacher. So one teacher is responsible for a course. That would be a one-to-many relationship because one teacher can teach multiple courses. So I teach business technology innovation, I teach social media at work, I teach communication theory. So I teach multiple courses, but those courses are only given by me in this example. So that's a one-to-many relationship. And that's why the one is here. So a lecture teaches a course, and a course is taught by one lecture only. So that's why we say a one here and an n as in many one. Well, of course, you can also reverse it. So whatever you want. So it cannot be both reversed. So if else it would be a one-to-one relationship. So if a course can only be taught by one lecturer and one lecturer can only teach one course, the relationship would be one-to-one. But it can also be that we say, no, okay, each course can be taught by multiple teachers, and that's it. And then it would be one-to-many reversed. Yeah, so in your database assignment, you also need to add the one and the ends. Yes. But you have to remember that there is nothing in the database software or database language or nothing in the technicalities that forces us to define the relationship between student and courses as many-to-many. That's just what happens in the real world. So a computer would be just as fine if we say a course can only be taken by one student, or a student can only take one course at a time. A computer doesn't care. It's only because we say that students can take multiple courses and the course can be taken by multiple students that it's a many-to-many relationship. There's nothing, so we have to tell the system that. There's nothing in the system that makes it so. Yeah, so if so the relational database for this pre-master with each course is taught by many teachers, the only thing that would change here is that this one would become an N. So a lecturer can teach more than one course, but one course is also taught by more than one teacher. So that's the only thing that would change. And that's of course, that what would happen in real life. Okay, so this is one. So this defines the relationship between the tables. Next one. This is how you can display tables without information in it. So without the data in it. This is an entity in an entity relationship diagram. So this is the entity student, this is the entity course, this is the entity teacher, And these are the fields in the table, so the fields in the entity. So the entity student, so the table student, consists of student number, last name of student, first name of student. So this is the same as this one, only here it has data in it, and this is only a description of the entity. And this is what you have to do for the assignment. So for the assignment, you don't have to fill the database with data. You just have to give me the entities, so these things, and the relationships between them. So basically for the assignment, the only thing you need to do is give me a figure, something like this, but then a bit more complicated. So just give me a figure like this. So the relationship between course and teacher, the relationship, sorry, the entity course, the entity teacher, which columns, which fields are in the entity, and how are they related. So that's the thing you have to do with an explanation for a database assignment. Yeah, so this is the setup of the tables as well. Yeah. Only for the assignment it's a bit more complicated. And exactly, you refer to the underlined entity for the relationships, because if you have, indeed, if you have, I don't know if you have noticed, some of you have done so indeed, the underlined are the primary keys. Yeah, there are special database tools to do this, but so you can do this in Access, and there are specific tools that you can use to create entity relationship diagrams. So if you Google entity relationship diagram software, you will find it, but it's just as easy to do with Word or PowerPoint. Or for the assignment, you can also just draw it and take a picture of it with your phone, as long as I can understand. I'm not sure. So the question is, maybe I'm a bit ahead, but is it true that you do not put all the keys of cells you would have in the tables in these entities? Can you explain what you mean by keys? So because for me, a key is now a primary key or a foreign key, and that's the course ID and teacher ID here. So I'm not sure if you mean key here. So yeah, you should also use the ERD cardinality lines. So that's basically to indicate the type of relationship between the tables. So one-to-one, one-to-many, many-to-many. And M means many. So it's either N or M. And there's also official notation, which is called crow's feet notation, which is a graphical representation of one-to-many. But one is always one, and many can be N or M or many or whatever you want. Yeah, okay, yeah. So with keys, you mean fields. So you mean the attributes, the columns of the table. And for the assignment, yes. So in the assignment, there is a description of all the information that should go in the database. And you have to pay attention to the assignment instructions. And that gives you the answer to which fields should be in the figure here. So which fields should be in the entity relationship diagram. And you should list all those that you think are necessary. If you know how the crow's feet work, you can use the crow's feet as well. Only then I first have to look up how they work again, because I always forget how they function. Well, this is explained already. So basically, that's the most, except for one important thing, that's the main thing you need to know. There's only one problem. So that's the problem we just identified. What happens if we have a relationship which is many to many? Because there is no good way of designing the database in order to represent a many-to-many relationship. So I'll get to that in a minute. Just let me give one example of a one-to-one relationship. So this is a one-to-one relationship. So here we can see that the teacher has one office, and one office is only occupied by one teacher, period. So that's a one-to-one relationship. And to be really honest, one-to-one relationships don't really happen all that often in databases because they're not necessary. If you have a one-to-one relationship, you can just combine them into one big table. So in a one-to-one relationship, so for example, each teacher is connected to one office, and one office is only occupied by one teacher. So that will be a one-to-one relationship. In a database, that doesn't happen all that often. Frankly, nowadays, almost never. You have one-to-many relationship, what we talked about just now. So in this case, and again, this is not what happens in real life at the university, but say a teacher can teach multiple courses, but a course is only taught by one teacher. That would be a one-to-many relationship. And finally, we have a many-to-many relationship. So for example, the relationship between students and courses. So a course has more than one student, and a student can take more than one course. And of course, this is very simple to solve in an entity relationship diagram, you'd say, because you can just say, okay, I just draw a line and I say, this is a many-to-many relationship. We're done. But it doesn't work that easy, because as we saw in the lecture, in the example, there is no good way of doing this into Excel. Yeah, the difference between N and M here is just for me to make clear that it's about different entities. So I use M for course and N for students, but it's all many. So you're right that it's a bit confusing. So you can just say N or M here, or many here. So sorry, it's a bit confusing. So it's all many. So like we saw in the example here, you know, when I when I added this table, that there was actually no good way of doing this without making the data redundant. So actually what you have to do when you have a many-to-many relationship in a database, you have to create a new table which connects the two tables. And the new table has one-to-many relationships between the other table. Completely unclear, but it's this. So if you want, let's see, we have an example with data here now. So if you want to actually in a database physically connect these two to each other, you have to create an extra table. So you have you create a table which is called students_course or whatever. And there you combine student number and course ID. Yeah. So, and it would probably, I'm going to open Excel. So suppose we have a table with a table students. It has a student. It has a student ID. It has name, etc. So this is the name of the table. These are the fields. Student number 1, which is Alex. Student number 2, Jan, etc. So we have another table called course. It has a course ID number, CID, and it has a course name. This is bold. Course number 1, course number 2, student, and name is. So these are two. No, that's niks. So these are two tables. Table 1 and table 2. So you can just say, okay, there's a many-to-many relationship, so I just draw a line between these two. So I just do this. Okay, they're connected. Well, but it doesn't work in real life. So how can I combine them? Well, I can create an extra table, which is called, it was called student underscore course. Let me write it out, students underscore course. And that table consists of student number, so student ID, and course ID. And I can now simply say student number 1 takes course number 1. Student number 1 also takes course number 2. Student number 2 only takes course number 1. Student number 3 takes course number 1. Student number 3 takes course number 4. Student number 3 takes course number 6. Student number 3 takes course number 7. They're not in here, of course, so I didn't create the tables, but this would be the way to connect them. Clara, your question is a bit long, so I'm going to continue this now for the moment and then answer your question later on. So this would be the way to connect the two tables. With this we know, okay, student number 1 takes 2 courses, number 1 and number 2. Student number 2 only takes 1 course. Student number 3 takes 4 different courses. But we can also do it the other way around. So if you want to know how many students take course number 1, we just count the number of courses here. And we know, okay, course number 1 is taken by 3 students. And this is now a one-to-many relationship. So because now we have a one-to-many relationship between this one and this one. And we also have a many-to-many relationship between this one and this one. So suddenly we have, two one-to-many relationships instead of one many-to-many relationship. And this is how, basically, if you design databases, this is basically what you do on a daily basis. So you try to see how you can create diagrams like this and connect them to each other. And let me go back to the PowerPoint. And this has all kinds of advantages besides simply connecting the two, because Now, if I want to enter the grade of a student for a specific course, I can just enter it here. So I can have a new column with grade. 7, 6, 8, 4, 5. So this table would also be the best table to add the grades, because a grade is what a student has for a certain course. Wait, just wait all the questions. Do we also mention them as SID, your combination mentioned for a minute to mention relationship? I don't understand the question, I think. Do we also mention them as SID, CID combinations mentioned in the assignment for a many-to-many relationship? Yeah, for a many-to-many relationship, so for the assignment, you just create something like this. So you create an intermediate table, students underscore course, which links the two. So you create something like this. And if you call them SID or CID or program or course or Q17, whatever. So that's just the naming convention is yours. I don't understand if you have to put all the information you know about, for example, the student in the entity, because what if you know the phone numbers and address? Yes, so the reason that I did not put this in the entity is simply because to make it simpler, because in reality here there is a lot. There is a phone number, there is mobile phone number, there is address, there is house number, there would be city, postal code, birth month, birthday, birth year, birth, etc., etc. So there would be dozens of attributes in the table. So the only reason I did not do that here is because it's confusing. So basically, Lizzie, you're right. Everything you know about the entity is in one table. So I only gave a very simplified example here. Let's see, what do we have? Yeah, so in the assignment, it states we should convert many-to-many relationship in a one-to-many relationship. Can we show that the same as you did this in the example with your students? Yes, exactly. So the problem in the database assignment is exactly the same as the problem in this case. So we have students and courses. We need a way to tie them together, and we do that with an additional table. So that's the exact same thing you should do in the assignment. Yes. Yeah. And for the assignment, you should put everything you know in the entity for the assignment, because if you read through the assignment, it's like 10 different attributes or 10 different fields or so, or maybe less even. Yeah. So in the Margot, yeah, thanks. Okay, now I understand your question. Yes. Yeah, thanks. Because this one, the student course table, contains the primary keys of both other tables. So the student course table contains the primary key from both the student table and the course table. So yes, both of them in here. Yeah. And you will see when you work on a database assignment, but you can also see from this example that this kind of solves a lot, because if you want to know when the student exactly took the course, if you want to know if the student took the course more than one time, if you want to enter the grade, if you want to enter the evaluation the student gave to the course, you can all enter them into this linking table. So because, for example, if you want to know, so for example, you get an evaluation questionnaire after taking this course. So we have to store that somewhere. Of course, you cannot store all because every evaluation is given by a student, so you cannot store all of that into this table, but you can store it here. We don't because it's anonymous, but we could. So grades, you cannot store grades in the student table, because as a student, you don't have one overall grade, you have a grade per course. So that's why you have to enter grades here. Yeah, very good question, but yes, very good question, yes. You're right that a linking table like this does not necessarily have to contain a primary key itself. Usually, but I was just lazy here, usually they do. So usually you just enter a number, ID or whatever in the table to make sure that it also has a primary key. But you can also say, we don't give a primary key to a linking table like this because the combination of student and course together is a primary key, which in this case is not true as well, because a student can take a course multiple times if he failed the course once. So what we did in Excel just now was make too many instead of one too many. No, the other way around. So what we did in Excel was, so we had a many-to-many relationship. So this was many-to-many relationship. And we turned the relationship into a one-to-many relationship. Well, two one-to-many relationship. So we did that in Excel. It would be really welcomed if your layout would be a bit better than my layout here in this Excel table. It makes reviewing the assignments a lot easier, but that's basically. And also in your assignments, you don't have to do this because this contains data. In the assignment, you need to do this. Sorry. You need to do this. So create something like this. So yeah, there's a lot of other slides, but I think I already explained these. Yeah, periods and grades are just some extra information that you need to fill in, but the assignment is not about students and grades. The assignment is about something else. But you do have to think about, okay, there are a number of fields in the assignments, and some will need to go in one table, others need to go in another table, and other needs to go into the linking table. So you need to think about that for the assignment. And also for the assignment, and also in database design, you have to think about what do we need into the table and what can we calculate. So for example, if I want to know a student's average grade, I could enter student's average grade here. So I could just say Alex's average grade is a 6. But I don't have to, because I can calculate my average grade from this table. So I know Alex is student number 1. Student number 1 is in the table 2 times with a grade 7 and 4. So Alex's average grade is 5.5. And that's also a real advantage of a database, is that you can calculate information from the data in the database instead of storing it on multiple places. So for the assignment, the basic thing you need to do is provide table figures like this, so student grades, courses with the relationship between them. But and also give a short summary, a short explanation of what this basically means. Because of course you are going to give the table, you are going to give these entities different names. You're going to give the fields different names, and I don't know what the fields mean. So you have to explain that to me. So if you have a table called ID or called QR or whatever, you need to explain to me what QR means, because I, of course, wouldn't know. So you have to give a short explanation. Yes. Sorry, let me get back to your question, Clara. The A-array cardinality that we should use is the only one that you showed us in the previous slide, because it's on a lucid chart program that you have other types of keys that would also make sense for the assignment, like one-on-one. Yes, so if so you can so there is one simple solution which is not perfect for the assignment, but you can extend the assignment with other types of tables which are linked one-to-one. And there is exactly there would be actually a good solution in which you have a one-to-one relationship in the assignment. So if you know how this works, and if you know how to create other types of relationships, and if you think that would be better for the assignment, yes, that would be a good solution. So finally, the assignment deadline is the 22nd, I think. And in the last lecture, I will give some explanation about the assignment and tell you how you did. Then I'm going to explain a few more things about databases, not that much. If you read through the other slides, it's just other examples of what relationships there are. But I'm going to give a bit more explanation using your assignments as an example. So we'll do that in the last lecture, because then I can give a few examples of the assignments you handed in. Finally, don't worry about the assignment. So I know this is difficult. And I know that some of you will come up with a solution that is not correct. If you come up with a solution that is not correct, you will still get a pass. You only get a fail if it's completely wrong. So if, for example, if you did not attend this lecture or did not pay much attention and you come up with something that is not related to an anti-relation diagram at all, I will ask you to redo the assignment. But basically, if you come up with a wrong solution, but I can see that you have put effort into the assignment, that you have thought about it, then you will get a pass. So don't worry about it too much. The whole idea of the assignment is to let you think about, okay, how would this be related? Because it's very simple to say, so for example, okay, I'm going to start a website and customers can order stuff through the website and then I'm going to send it to them. Very easy to say something like that, but it actually finally has to end up somewhere in a system that you can use. And the reason for this assignment in this lecture is to let you think about what's behind all that. Now, you don't have to make the tables. You don't have to, you only have to do the ERD. Even more so, you cannot give tables because there is no, in the assignment, there is no data given. So in the assignment, it's only the database itself, but there is no, in the assignment, there's no list of students, or specifically, there's no list of programs. So this is not correct. This is just the example. This, with the connection between them, is correct. So let's keep it at that. And then using your assignments in the last lecture, I will explain a bit more about databases, tell something about what exactly the use is and how handy databases can be. But let's stick with this for now. If you have additional questions about the database assignment, so feel free to email me, or maybe better to, if you have additional questions, to put them in a discussion forum on Canvas, so everyone can see the questions and the answers. But you can also email them. So let's stick with this for now, and good luck with the assignments and the business plan, of course. And I'll see not all of you, but I'll see some of you on Wednesday. Yeah, for the exam, finally, I can ask some questions, and I will, about what would be the primary key, what type of relationship would this be, So I will ask, let's say, 1 or 2 multiple choice questions about databases, but it will not be an open question in the exam. And it will only make up a small part of the exam, so there's 1 or 2 questions. Okay. So if there are no more questions for now, then thank you very much for this part of the lecture, and good luck with the database assignment, but focus on the business plan for now. And I'll see you on next week or this week during the work groups. So thank you very much, and good luck.